long as human eyes have turned upward, the night sky has been both a map and a mystery. We have charted its constellations, woven its patterns into our myths, and built grand theories to explain our place within its vastness. Yet every formula, every law we thought immutable, has now been unsettled, perhaps even overturned. The James Webb Space Telescope, the crown jewel of our technological ambition, was built to glimpse the universe's earliest light. But what it has revealed is not simply beauty. It has uncovered a reality far stranger than the one we thought we inhabited: galaxies impossibly ancient, planets inexplicably vast, structures unnervingly precise, and a signal whose steady pulse feels less like nature and more like intention. None of these fit within the comforting boundaries of our current science. This is not just discovery. It is a challenge, a direct confrontation with the limits of our imagination. In its deepest surveys, Webb turned its gaze toward the galaxy cluster Able 2744 and found something that should not exist: points of light arranged with uncanny symmetry, as though someone had sketched them into place. In the spiral galaxy NGC 1365, its instruments traced motions so peculiar that they seemed to mock our most basic laws of gravity. And the further Webb looked, the more unsettling the view became: patterns recurring over unfathomable distances, order where chaos was expected, geometry stitched into the very fabric of space. One of Webb's more curious targets was an exoplanet designated HIP 65426b, lying hundreds of light years away. What it revealed left astronomers grasping for explanations. 7 times the mass of Jupiter, orbiting 3 times farther from its star than Neptune does from ours. It circles a sun scarcely 15 million years old, a cosmic infant. By the rules we know, such a giant should not be there. There is no disk of debris to form it, no surplus of matter to feed it, no stable path to keep it in place. Some whisper it might not belong to the system at all, that it is a relic from an earlier age, a world transplanted across time and space. Elsewhere, Webb captured an Einstein ring so flawless it borders on the impossible. Light from a distant galaxy bent by another in perfect alignment, forming an unbroken circle of brilliance. For such precision to occur, the positioning of these galaxies must be exact to within a fraction of a degree across billions of light years. Coincidence becomes difficult to argue. Could this be a glimpse of some hidden symmetry in space-time, or is it the hint of a deeper design, one written into the blueprint of the cosmos itself? Then came the finding that shook cosmology's very foundation: massive, mature galaxies, already fully formed a mere 180 million years after the supposed Big Bang. In our models, such grandeur should have taken billions of years to assemble. And yet, here they were: spirals as vast as our Milky Way, burning brightly at a time when the universe was supposed to be little more than a turbulent haze of gas. If these observations hold true, then perhaps the Big Bang was not the absolute beginning we believed it to be. Perhaps there was a story before our first chapter. In another survey, Webb peered into a seemingly empty region of space, devoid of stars, galaxies, or any visible structure. Yet the light from more distant galaxies curved as though something unseen and unimaginably massive were lurking there. We call it dark matter, but even that term is little more than a placeholder. The lensing here was too sharp, too localized, too deliberate to resemble the diffuse clouds we theorize. It behaved like an object defined, shaped, almost architectural. Could it be the fossil of something built, still casting its gravitational shadow long after the builder vanished? And then came the cosmic filament, an immense strand of galaxies and dark matter stretching more than 1 billion light years, aligned with a precision that mimics the lines of a vast grid. Our models suggest such formations emerge naturally over time, sculpted by gravity. Yet this one defies the expected randomness. Galaxies marching in parallel lanes, matter clumping at fixed intervals, even redshift readings pulsing in waves. As though we are seeing the scaffolding of the universe itself, more radical minds have begun to wonder if dark matter might not be silent at all. Perhaps it carries within it something akin to memory, a record of what the cosmos once was, echoing its past into its future. Webb's observations have hinted at this galactic clusters arranged like mirrors of long-vanished ones, repeating across epochs. If this is true, then every swirl of starlight could be an echo from a time before time, a whisper from a universe that remembers its own history. But among all these enigmas, one stands apart. During a deep scan of an empty void, Webb detected a series of faint, regular pulses. They did not match any known stellar source. They were not the erratic signatures of quasars or the clockwork beats of pulsars. They came, precise and measured, from a place with no heat, no mass, no visible body, only light, appearing and vanishing in exact rhythm. Every possible error was ruled out. The pattern remained. NASA has chosen silence on the matter. Yet behind closed doors, the question lingers. What if these pulses were not sent to be heard, but merely to be noticed? And if they are a signal, who or what was meant to see them? The James Webb Space Telescope was built to pull back the veil of time. Instead, it may have uncovered a truth we were never prepared to face, that we are not adrift in a meaningless expanse, but participants in a structure, a system, perhaps even a design. Galaxies that defy our timelines, planets that mock our physics, structures that echo intelligence, patterns that feel less like accidents and more like intention. If the universe remembers, then we are part of its memory. If the pulses are deliberate, then perhaps they are not just data, but a welcome or a warning. And if what Webb has shown us is real, then our long-held image of a cold, indifferent cosmos may need to be abandoned. Perhaps we have never truly been alone, not in space, not in time, not even in thought. Perhaps the universe has been waiting for us to look deep enough to see it for what it is. And now that we have, the stars will never look the same again. So we are left with the question, are these wonders evidence of something greater, or are they reflections of our own longing for meaning in the void? The answer may change not only our understanding of the cosmos, but our understanding of ourselves.